Have you ever pondered why the universe, as we know it, is predominantly composed of matter and not its eerie twin, antimatter? Antimatter, a term that often pops up in the realm of science fiction, is not just a figment of creative imagination. It's real, and it exists. But its existence in the observable universe is as rare as finding a needle in a cosmic haystack. This beguiling cousin of matter is made up of antiparticles, counterparts to the particles that make up the world we know and live in. Yet, the question that baffles scientists is why the scales of the universe tip heavily towards matter, leaving antimatter as the cosmic underdog. This perplexing disparity, often referred to as the asymmetry between matter and antimatter, is one of the unsolved mysteries of modern physics. It's like a cosmic riddle waiting to be solved. Understanding antimatter isn't just about satisfying our curiosity, it's a key to unlock the fundamental secrets of the universe. So what exactly is this elusive antimatter? Well, let's dive right in. Antimatter is like the mirror image of matter. It's made up of antiparticles, which are identical to the particles of matter but have opposite charges. Consider an electron, a negatively charged particle. Its antimatter counterpart is a positron, which is positively charged. Now think of antimatter as the yin to matter's yang. They might seem like polar opposites, but they are intrinsically linked. In fact, when matter and antimatter meet, they annihilate each other. This might sound like a destructive process, but it's also a profoundly creative one. You see, this annihilation releases energy, and not just a smidgen of it. It's a process so potent that it makes nuclear fusion look like a candle flame. Let's put it into perspective. A gram of antimatter reacting with a gram of matter would release about twice the energy produced by the explosion of the atomic bomb dropped on Hiroshima. Now, that's a staggering amount of energy. So if we could harness this energy, the possibilities would be mind-boggling. Imagine powering cities with just a few grams of antimatter, or spacecraft that could reach the stars in a fraction of the time it currently takes. Antimatter could revolutionize energy production, making our most efficient methods today look downright primitive in comparison. But here's the catch. Antimatter is incredibly rare. We know it exists because we've been able to create minute amounts in particle accelerators. But in the observable universe, it's scarce. And this is one of the biggest mysteries in physics. If the Big Bang created matter and antimatter in equal parts, why is there so much more matter than antimatter? Despite its potential, we've barely scratched the surface of understanding antimatter, and its scarcity remains a puzzle. If antimatter is so elusive, where might we find it in the universe? This is the question that has piqued the curiosity of scientists for decades. Theorists and experimentalists are working tirelessly to unravel this cosmic conundrum. One possible place to find antimatter is in high-energy cosmic rays. These are not rays in the traditional sense, but rather particles that zoom across the universe at nearly the speed of light. Some of these particles are thought to be antiparticles, the antimatter counterparts to the matter particles we know. Astronomers also keep their eyes peeled for signs of antimatter in the cosmos. They use powerful telescopes to detect gamma rays, which are produced when matter and antimatter annihilate each other. This is yet another clue in the search for the elusive antimatter. The quest for antimatter is a cosmic treasure hunt, with the treasure being an understanding of the very nature of our universe. So what have we learned out about antimatter today? We've dived deep into the essence of antimatter, understanding it as a counterpart to matter, with properties that mirror those of the matter we're familiar with. Each particle of antimatter corresponds to a particle of matter with an opposite charge. We've also explored the profound mystery of why the universe, as we observe it, is overwhelmingly dominated by matter. The Big Bang theory suggests equal amounts of matter and antimatter should have been created at the birth of the universe. Yet here we are in a universe filled with matter and only minuscule traces of antimatter. The reason for this imbalance remains one of the greatest unsolved mysteries in physics. We've ventured into the ongoing search for antimatter, a quest that continues to challenge and inspire scientists around the globe. The universe still holds many secrets, and antimatter is one of those enigmas that continue to intrigue us. Until we solve this puzzle, the quest for understanding our universe remains an exciting journey of discovery.